This is 9.1.1b, Intro to Identities. So we're going to use identities to manipulate an expression or equation. Now remember, these are the identities that we need to memorize. You need to memorize the reciprocal, the tangent, and the Pythagorean identities. It will get easier as you memorize these. If you don't memorize them, they will always be a struggle. I'm letting you know. And again, it will always be a struggle if you don't memorize these. So helpful things, and you should already have this stuff written down. You should look for larger identities: Pythagorean, double angle, sum and difference, power reduction, etc. Then look for algebra. Then change everything to sines and cosines and repeat. So for this one right here, this is ones where it fails all three. There's no large identity. I don't see sine squared, cosine squared, etc. I don't see any algebra. And I don't see sines and cosines. Usually when that happens, it's going to be a conjugate situation. See how it's like sines and cosines switched? It's like somehow this turned into sine or cosine. So remember, setting it up, you can only manipulate one side. So I'm going to multiply by 1 minus cosine theta. And just remember, it's just because the conjugate, you just know it changes something. Now if I multiply this out, you get 1 minus cosine theta plus cosine theta minus cosine squared theta. That cancels out. So you get 1 minus cosine squared theta over sine theta times 1 minus cosine theta. Now see, look, I got my 1 minus cosine thetas on the bottom. So now it's like, oh, I got to get rid of the sine. So go back to the list. First, big identities. Do I see anything Pythagorean? Oh, I see cosine squared. So sine squared theta plus cosine squared theta equals 1. How do I get that identity to look like 1 minus cosine squared? Well, if I subtract that, you get 1 minus cosine squared theta. So I know 1 minus cosine squared theta equals sine squared. So I'm going to replace it. Substitute it. Now the sines will cancel out. And so now those will reduce. So that's the same. There we go. So for this one, any big identities? No. Any algebra? No. So now I'm going to switch everything to sines and cosines. So this stays cosine. This becomes 1 over cosine. Okay, back to the top. Any big identities? No. Any algebra? Yes. This reduces. So I get 1. So for this one here, this one it's like, does the left side or does the right side, which one is like better, right? Now if we think of the list, it's like, okay, Pythagorean identities. Yes, maybe on the left, right? Because I have a sine squared on the bottom. Nothing big on algebra on either side. But on the right side, it's cosecant and cotangent. I can change everything into sines and cosines. That's the third step. Now, going back to the first one, maybe it's a Pythagorean, but there's no guarantee it's going to turn into something. But at least I know on the right side, I can definitely turn something into sines and cosines. And if you look at the left side, it isn't sines and cosines. So maybe I need to do the right side, but let's test it out. So no big identities, there's no algebra, but if I change everything into sines and cosines, cosecant is 1 over sine, cotangent, the quotient identity is cosine over sine. Now I know you're thinking, well, isn't cotangent 1 over tangent? Yes, but I'm suggesting you change everything to sines and cosines. So what's the cotangent version of sines and cosines? Cosine over sine. Multiply those together. Those are the same. And you have your answer. So what did we learn today? We explored identities further and investigated them further. Remember, we should memorize those identities. This does conclude our lesson. If you have any other questions, please leave them